Hi, I'm Patrick Hill, Deputy Project Manager for NASA's Parker Solar Probe. I'd like to take you on a tour of the pioneering spacecraft designed, built, and soon to be operated by the Johns Hopkins Applied Physics Laboratory. In just a couple of weeks, a Delta IV Heavy launch vehicle will rocket Parker Solar Probe out of Earth's atmosphere and begin its long-awaited mission to touch the Sun. There are three main technologies on Parker Solar Probe that make this mission possible. They all play an integral part in keeping the spacecraft and instruments safe, healthy, and operating at peak performance. The Thermal Protection System, or TPS, is an essential technology that enables Parker Solar Probe to get so close to the Sun. The TPS is a composite structure formed from a top and bottom carbon face sheet with 4.5 inches of carbon-carbon foam between them. Together it forms an 8-foot diameter heat shield that sits on the top of the spacecraft. The outer sun-facing side of the TPS is then sprayed with a bright white optical coating invented by Johns Hopkins University. This new material does an amazing job of reflecting the sun's heat. The TPS is incredibly light. It only weighs 160 pounds, yet it's very effective at reflecting the sun's energy. During closest approach, the sun-facing side of the TPS will see temperatures around 2,500 degrees Fahrenheit. Meanwhile, the spacecraft itself will be closer to room temperature, around 85 degrees Fahrenheit. Everything hides behind the shadow or umbra of the TPS, except for a few brave instruments: the field's electrical wave antennas and the SWEEP Solar Probe Cup, both of which have their own heat shields. Like many spacecraft, Parker Solar Probe is powered by solar arrays. There are two on each side of the spacecraft, currently hidden beneath their protective covers. What's different about our solar arrays is they must operate within the final 5% of the distance between the Earth and the Sun. That's too much energy for conventionally designed solar-powered systems. The first thing we do is use the actuator motors to move the solar arrays behind the umbra of the TPS, such that only the leading edges are exposed to the Sun. That small amount of illuminated surface produces enough energy to power the spacecraft and all of the instruments. The spacecraft uses an innovative cooling system that circulates water throughout both arrays. The heated water is then transported to these large radiators hidden behind the TPS, which then radiates that heat out to deep space. Parker Solar Probe is the first spacecraft to use an actively water-cooled solar array system. During solar encounters, the Sun itself blocks Parker Solar Probe from receiving commands from the Earth, and it must rely on its own autonomous systems to keep the spacecraft and science instruments safe. We've placed solar limb sensors all over the spacecraft to determine when it's receiving too much sunlight. Autonomy then determines how best to position the spacecraft by sending commands to the reaction wheels, which adjust the probe's position in space. Parker Solar Probe is one of the most autonomous spacecraft ever designed. Parker Solar Probe is a mission 60 years in the making, and it culminates the work of tens of thousands of people at NASA, APL, and our partners all over the country and all over the world. It's been an honor to work with such a deeply dedicated and knowledgeable team of scientists, engineers, and technicians. I can only wonder what we'll discover along our mission to touch the Sun.